Hello guys, how are you today? Sorry for posting this video late. I was busy yesterday, but anyways, without further ado, let me get started with the course practice of mechanics, okay? Section 3.5 till 3.8. We start with the very first question. A body A exerts a force on body B denoted by FAB, and the body B exerts a force on body A denoted by FBA. This is known as Newton's third law. What does Newton's third law state? For every action, there is a reaction. So we have a body A and a body B. The body A exerts a force on the body B, and the body B will exert a force on the body A. But what are the conditions of these forces? First thing is that always the force that A exerts on B is equal to the force that B exerts on A. Always. Even though they are equal, they have what? Opposite directions. Now, last but not least, they act on different bodies. They cannot act on the same body. So they act on different bodies. So what are the conditions for Newton's third law? The magnitudes of the two forces are equal, they occur in opposite directions, and they act on different bodies. So we can say that action and reaction act on different bodies, they have opposite direction, and they are equal in magnitude. We move on to question number 2. What does it say? It says the below figure shows a trolley, this is the trolley, accelerating towards the right. So pay attention to the acceleration. With the mass m placed against its vertical from the surface, take g to be 10 meters per second squared. What minimum acceleration? What is the minimum acceleration they're talking about? Should the trolley have for m not to slip, knowing that the coefficient of the static friction between m and the trolley is 0.4. This is the coefficient of the static friction. Anyways, we have everything that we know in front of us. First of all, we know that g is 10 meters per second squared. We also know that it has a mass m. They didn't tell us the value of the mass. And that the coefficient of the trolley is how much? The coefficient of the trolley is 0.4. This is the coefficient of the static friction. Now, anyways, let us get to drawing the free body diagram. So how do you draw a free body diagram? You start with excluding everything except the object that's being acted upon and the surface. So we have the surface of the trolley, the object that the forces are being acted upon. Now we start by what? By drawing the forces, not that the block exerts, not that the object exerts, but rather that's exerted on the block. We first of all start with the fact that it's on a surface. That means it has a normal push. So the normal push will go like this, because it's always perpendicular to the surface. Then we always have the weight that goes downwards. It's always downwards, perpendicularly. Okay, and then what do we have? We have the force of friction over here. So they want the value of what? Of the acceleration, in order that m will not slip, right? So if m does not slip, that means for sure we are dealing with what? With static friction, okay? And in all scenarios, they told us that the coefficient of static friction between m and the trolley is 0.40. So they already stated that it is static friction. Okay, so what is the equation we need to know? First of all, we need to know that the static friction is equal to its coefficient multiplied by the normal force. Honestly, I prefer in the free body diagram not to draw the friction like that, because this is how AP is supposed to draw it. My teacher mentioned it like this, but it's more preferably, in my opinion, like to draw it from the center. But if you want to get the mark, you need to draw it from the bottom here, not from the center, because that's the friction. And as well, additionally, the normal is supposed to reach the surface. So if you want to get like a proper mark for the free body diagram, you need to follow all of the rules. Now, what can we say? Because it does not slip, it stays as it is even though the trolley is moving like this. We can directly state that sigma Fy, meaning the sum of the forces up with the forces down or on the y-axis, is equal to 0. They literally cancel out, so it will not move up, it will not move down, it will stay in the place that it is, so it will not slip. However, the sigma fx is different. We don't have another force to counter the normal push. Instead, sigma fx is gonna be equal to what? It's gonna be equal to ma, because it's not equal to 0, it's accelerating, and every time there's an acceleration, that means either sigma fy or sigma fx is equal to ma. It depends on how it's accelerating. Since it's accelerating to the right, then directly sigma fx equal ma. If it was accelerating up, then it would be sigma fy equal 0. Up or down, sigma fy equal ma. If it's up or down, and if it's left or right, then sigma fx equals ma. But anyways, we know that sigma fx is equal to ma, right? What is sigma fx? The only force we have on the x-axis is what is the normal n. Let me just label all of the forces here. This is the normal n, this is the weight w, and this is fs, okay? So, what does that mean? That means the normal n is equal to what is equal to ma. Additionally, we know that sigma fy is equal to 0. What does that mean? That means everything up equals everything down. So fs is gonna be equal to w, and w is equal to m times g, so fs is equal to mg. Now we come back to this equation over here. We know that fs is equal to mg, right? So we can substitute fs by mg. It's equal to what? It's equal to the coefficient, which is what? Which is mu s times n. And what is n? N is ma. So here we use this, and here we use this. They gave us the value of ms to be what? To be 0.40. So we can substitute ms by 0.40. What can we do now? Also, we can cancel the mass m and m. Can cancel them, and now you're left with g is equal to 0.40 times a, and they gave us the value of g to be 10. So 10 is equal to 0.40 times a. A is then equal to 10 over 0.40, which is what? Which is 25 meters per second squared. And just like that, we got the value to be 25 meters per second squared of what? Of the acceleration. We'll move on to question number 3. What does it say? In question number 3, it says a body is subjected to a constant net force. They said constant net force, meaning net force is equal to ma. Why did I say this? If they said no net force, that means net force equals 0. This means what? This means it's either at rest or it's moving in a constant manner, meaning it's moving in a constant velocity, or in other terms, URM. But they didn't tell us that the net force is 0. They told us it's a constant value. What does this mean? First of all, the net force is what? A constant value. So we can write constant. And no matter what we do, we increase the force, decrease the force, increase the acceleration, decrease the acceleration, the mass is always going to stay what? It's always going to stay the same. So mass from the beginning is what? Is a constant value. Now what's left? Now what's left is to determine the acceleration. Constant equals constant times what? Times constant y. Because if you multiply constant by a variable, you're gonna get a variable answer. However, if you multiply a constant by a constant, you will get a constant answer. So what does this mean? This means our acceleration is what? Our acceleration is constant. So the body experiences a constant acceleration. Now, when choosing our option, we need to choose the the safest option, the option that will be true in all cases. The first one, the body moves at a constant speed. If it does move in a constant speed, there would be no acceleration, because acceleration causes the change in velocity, which is what? The change in speed velocity is basically speed having a direction, and acceleration is the change of velocity. So if there's a constant speed, meaning a constant velocity, meaning there's gonna be no acceleration. So this is why this is wrong. The body moves in a straight line, but its speed may vary. This is true if the force is along the direction of motion. Yes, this is true. Like if it's moving in a straight line, this statement is absolutely correct. But we're not sure what is the direction. They didn't tell us about the direction. It could be a curved path, okay, like uniform circular motion. Yes, it could be like that. And it could have a constant net force, meaning constant acceleration. So for sure, this is wrong. The body experiences a constant acceleration. This is true. And this is true because there is no specification, right? So for sure this is true. So like as long as there is no specification in direction, it will be true. Now the body's acceleration changes over time. No, it's constant. And then the body undergoes uniformly accelerated motion in a straight line. This is true only if it's moving in a straight line, but we don't know how it's moving. So it could move in any direction, not necessarily along a straight line. So this is why it's wrong, and this is why the only correct answer is the body experiences a constant acceleration. We move on to question number 4. What does it say? It says, a body of mass 2 kg is accelerated from rest by a steady force of 5 newtons. What is the speed of the body after it traveled a distance of 40 meters? So let us draw the free body diagram of what they described to us. A body of mass 2 kg. It has a mass of 2 kg. So how much is N? How much is W? How much is the weight? It's gonna be 2 times 9.8. You may ask me, Amanda, why did you choose 9.8? Because they did not give me the value of G. Whenever they don't give me the value of G, you need to use it as 9.8. So 2 times 9.8, that's got to be how much? That's got to be 19.6 newtons. Now what did they tell us? It's accelerated from rest by a steady force of 5 newtons. Now as well, what do we know? We know that there's a normal push, and the normal push in this scenario is gonna counteract what? It's gonna counteract the weight, so it's gonna be equal to the weight but in a different direction. And then we have a steady force of 5 newtons over here. Now this 5 newtons causes it to accelerate. If that's the scenario, if we do have acceleration, then we can state, first of all, that sigma Fy is equal to 0. Why? Because it's not moving upwards. Okay, this is just like how I'm assuming that it's not moving upwards based on my free body diagram. Okay, that it's not moving upwards, right? That means sigma Fy is equal to 0. But when we're dealing with sigma Fx, there's an acceleration. So directly, what does this mean? This means we can say that sigma Fx is equal to ma. Now what's the only force acting on the x-axis? It's the 5 newtons. 5 is equal to the mass, which is 2 kg times the acceleration a that we need to find. So we'll get the acceleration a to be how much? To be 5 over 2, which is 2.5 meters per second squared. Now that we have the acceleration, what can we do? You need to remember the equations of URM and UARM. Okay? If you did remember them, you would notice what we have. We have acceleration, we have the distance traveled, which is delta x, and we have v initial because it was what? It was at rest. And then you will remember this equation from UARM, which is 2 times a times delta x is equal to v final squared minus v initial squared, right? So it's gonna be 2 times 2.5 times okay, let's ignore this. I don't know why it keeps on coming. So 2 times 2.5 times delta x, which was how much for us? Which was 40, is equal to v final squared, which we need to find, okay, minus v initial squared. Because it was at rest, that means v initial was how much? It was 0, so minus 0 squared. That means v final squared equal 2 times 2.5 times. So v final squared is 2 times 2.5 times 40, which is what? Which is 200 meters per second. Now don't forget this is v final squared, so we'll need to do radical here and radical here. So radical 200 will give me an answer of what? V final being 14 meters per second. So what does that mean? That means v final is 14 meters per second. We'll now move on to question number 5. What does it say in question number 5? In question number 5, we have child A and child B are playing tug-of-war. So we have A and we have B. They're playing tug-of-war, meaning there's an arrow in between them. Child A pulls on the rope. What did they say? Pay attention to their statement. It's very important. Child A pulls on the rope, right? A tension force is created. So child A pulls on the rope. There's a tension force this way. Which of the following best describes the reaction force? Because this is an action. What's the reaction force of the tension? in the rope caused by the child A's pull? Very simply, you write down the statement and you start switching. First of all, you switch the two objects, child A and rope. So rope and then child A pulls, the rope will also pull child A. So the rope pulls on child A. This is true, so it's the rope that will pull child A. So it's the force exerted by the rope on child A. So the rope exerts a force on child A, so the force exerted by the rope on child A. We'll move on to question number 6. What does it say? It says 3 blocks of masses M, 2M, and 3M are pulled across a frictionless surface by a horizontal force T as shown in the figure. Which of the following is true about the tensions T1 and T2? First of all, we need to see that this tension T is responsible for pulling M, 2M, 3M. So T pulls what? Pulls M plus 2M plus 3M. It pulls these 3 blocks of 3 different masses. Okay, so this is something important to pay attention to. And then tension 1 pulls only 2M plus M. So in total this is 6M. In total this is 3M. And then tension 2 pulls only M. This is very important to pay attention to. Now we know it's a frictionless surface, so we have the weight, we have the normal push, they will counteract each other. So that means what? That means sigma Fy equals 0. If you don't write these in the written part, you're gonna lose marks, okay? And then sigma Fx, they said it's being pulled across a frictionless floor. If there's no friction, we have only one force acting, then directly you can say that sigma Fx is equal to what? Is equal to M. Or not only if there's one force, if you have 2 forces, but it's not at rest, okay? It's not at rest and it's not moving constantly, then directly we say that sigma F is equal to MA, either Fx or Fy. In the scenario, it's Fx, okay? So we start with tension T. Tension T is equal to the mass times the acceleration. What's the mass? The mass is 6m times the acceleration A. So let me write here, let me erase all of this, okay? And I will write that the tension T is 6 mass times acceleration. Tension of T1 is the mass, which is 3 mass times the acceleration A. And tension 2 is how much? Is mass times what? Acceleration times acceleration A. Now, because all of this is like one rope pulling the 3 blocks, this acceleration, these 3 acceleration are all the same. That means acceleration equal T over 6m. Acceleration equal T1 over 3m. Acceleration equals T2 over m. And they are all equal to each other, right? So, because all the acceleration is like always the same, and it's always the same in this like scenario that we're looking at, okay? So, tension 2 over m is equal to tension over 6m is equal to tension 1 over what? Over 3m. Now, I prefer not to do it like this because it's a bit confusing to solve, but if I solved it like this, I would get what? I would get 6T2m is equal to Tm. So I cancel m, and I'm left with 62 is equal to T. Not 62 as in 62, no. 62, okay? And then T1 over 3m is equal to, sorry, T1, yeah, over 3m is equal to T over 6m. You do cross multiplication, you will get 6T1m is equal to 3Tm. You cancel m and m, and then you move 3 to the other side. You will get what? You will get 2T1 is equal to T. So now we equate them all. We will get that T is equal to 2T1 is equal to what? Is equal to 6T2. So this is the correct answer. We'll move on to question number 7. What does it say? Now, question number 7. A pendulum consists of a bob suspended from a light string attached to the ceiling. The pendulum is released from rest, okay, at the position shown in the figure. If it's released from rest and it's like this, like think of it logically, and it's like this, the pendulum for sure is going to swing. So if it's swinging, that means the velocity is changing, and if the velocity is changing, that means we're having what? We're having acceleration, okay? Now, always, how do you draw the weight? You draw the weight down. So the force, okay, of the weight is downwards, okay? Now, personally, I will take from the string, this will be what? This will be my x and y axis, right? So this will be much easier for me to deal with. I have the tension of my string going up, and I have my weight going down perpendicularly, not according to the x-axis, but it's always going perpendicularly down. So now, if we needed to resolve the weight W, we would get a force here and a force here. How do I know? Very simply, do the parallelogram method. I have a force here, and the resultant here, right? How do I know my resultant is that way? I draw another force here that's parallel to this, and another force here that's parallel to this. I connect the tail to the head, and I will get my resultant force to be like this. This is how I know where my forces are. And if I resolve my force, where will they be? I have one on the x-axis and one on the y-axis. Now, logically speaking, when you hold the pendulum and you let go of it, the pendulum is gonna move like this, right? It's not gonna move up and down. So what does it mean that it's not moving up and down? That means the net force y is equal to what? Is equal to 0. Perfect. Now, what's remaining? The remaining is the net force of x. The only force acting on the net force of x is what? Is Wx, okay? So the net force of x, which is equal to Wx, is equal to what? Is equal to ma. Why? Because we said that it accelerates over here. Perfect. Now they're telling us which of the labeled arrows best represents the direction of the net force acting on the bob. We know that it doesn't move up and down, so directly we cancel the forces moving up and down, and we're left with only this this force, okay, and this force is acting on which arrow? It's acting on arrow 3, so this is why we choose arrow 3. Now we move on to question number 8. It's a very important question. Now, I'm not sure if we ever took something like this before, but I did some research, I checked some methods, and I was able to make some kind of sense out of it, okay? So they told us a highway curve has a radius of curvature of 50 meters and is banked. What do they mean by banked? They means the angle theta at an angle of 30 degrees. Okay, so the first step that I did was I do my free body diagram. It's a highway curvature. It looks something like this, right? Now, what do I have? I have my car that's on the curvature. Okay, this is my car over here. Let me fix it a bit. This is my car over here. Now I start as always by drawing the free body diagram and drawing the forces. I have the weight first of all. I have the normal force, and they said there's no friction. Now, there's something we need to know from a side, and that thing is that the acceleration on a curve is equal to what? Is equal to v squared over r. V squared is the velocity or speed squared, and r is what? Is the radius of curvature, okay? So, they want the ideal speed at which the vehicle can safely navigate. So, there's no force being exerted on the vehicle that will push it this way. Instead, what's causing this to happen is what? Is the normal. Now, of course, I need to draw my x and y axis, but I can't draw it on the normal because the normal it's tilted based on the curvature. When it's a flat line, yes, I can draw my x and y axis on the normal, but because it's a curvature, I cannot. So that's why I would always prefer to use it on the weight. The weight is always going downwards towards the center of the earth. So this is my x and y axis. So what's left for me now? What's left for me now is to resolve my normal into what? Into the normal y and the normal x. So this is my normal and this is my weight. Now, something important is that they told us this angle over here is how much? Is 30 degrees. So what I like to do, I like to draw a straight line and I like to let it pass here. So if this is the scenario, I have 30 degrees here and 30 degrees here. And what does this straight line do? This straight line passing through the origin creates 90 degrees with the normal. Okay, this is very important. So if this angle that I have over here is 30 degrees, right? And then this is how much? This is 90. So how much is the remaining angle over here? It's 60 degrees. Now, again, my angle here is how much? Is 90 degrees. So if this is 60 degrees, then this is supposed to be what? It's supposed to be 30 degrees. Now, I only use this method to find the angles so I can find ny and nx. Ny is equal to, this is my angle over here, right? Ny is adjacent, right? So that means I'm going to be using cosine. So n cosine angle, which I will call it alpha. Now what do I have? I have, this is my nx. But what I could do in this scenario, because I'm dealing with forces and resultant and vectors, I could draw a parallel to it over here. So this value over here is the same as this value in the bottom. So this over here, it's what? It's opposite to the angle, meaning that nx is equal to what? It's equal to n sine alpha. Okay, perfect. Now, as you can see from this lovely graph, I'm gonna erase it. Okay. Now that we have everything that we need, I'm gonna erase all of the unnecessary information. Now this is my free body diagram after resolving everything, okay? I have ny, I have nx, and I have w. What do I know? I know that the vehicle needs to be moving, right? Now a vehicle will not move up and down. So what can we say directly? We can say directly that ny is equal to w. So n cosine alpha is equal to mg. What's left for me is on the x-axis. Oh, also I can say that sigma fy is equal to 0. So it's moving now on the x-axis because we said that the vehicle navigates. They didn't say that it's constantly moving. No, they didn't say it's at rest or in inertia. So directly, we assume that sigma fx is ma. Since this is the scenario, sigma fx is ma, what's my only force on the x-axis? Nx. Nx is going to be equal to what? It's going to be equal to ma. Perfect. Oh, by the way, I called it theta over here. I can also call it alpha. I changed only like the naming in the middle. So this is alpha 30 degrees. And we know that nx is what is n sine alpha. So n sine alpha is what is ma. Now, we know because we're dealing with a curve, the acceleration is v squared over r. So we can substitute over here a into v squared over r. Okay, perfect. Now, what do I need to do? I need to get rid of n, and I need to get rid of m because I don't have the values of m, and I don't have the value of n. So what do I do in this scenario? I'll just divide here and here by which equation? By n cosine alpha equals mg. So n cosine alpha equals what? Equals mg. N over n, 1. Sine over cosine, tangent. So tangent alpha is equal to what? Is equal to m and m cancel. It's equal to v squared over r divided by g, or times 1 over g. So basically v squared over rg. But what do they want from us? They want from us the ideal speed. So we're talking about the velocity v. So we need to make it the subject of the equation. V is equal to tan theta. V squared equals, tan theta times rg. Get rid of the squared by doing radicals. So this is our final equation. Radical tan alpha times rg. So radical tan 30 times r, which is 150, times g, which is 9.8. Put it on the calculator. Radical tan 30 times 150 times 9.8. That's going to be what? That's going to be 29.1, or approximately 29 meters per second. We'll move on to question number 9. What does it say in question number 9? The form of energy liberated by friction. So if I move my hand on the table really fast, or even if I rub my hands together, this is two surfaces sliding on each other. This is what? This is friction. What do I feel? I feel heat. So I will feel what? Warm. And what's the definition of warm? It's thermal energy. Question number 10 is similar to question number 8. A car rounds an unbanked. Now, when they say unbanked, that means directly theta is what is 0 degrees. Curve of radius 250 meters at a speed of 20 meters per second. Okay, a car rounds an unbanked. Unbanked means theta is 0 degrees. Curve of radius 250 meters at a speed of 20 meters per second. What is the minimum coefficient? Mu. Okay, minimum coefficient is denoted by mu. Of friction required to prevent sliding. So prevent sliding, meaning that it's not moving, meaning what? Meaning mu s. Now, we know that mu s times n is equal to fs. That means mu s is equal to fs over n. Also, what did they mean by unbanked? So it means like this, I believe. Right? So it could look like this. And then I will have my car where? I will have my car over here, okay? And then from my car, what is the two forces I have acting? I have mg down and I have mg weight down, and I have the normal force n. Now, they told us that it's not at rest, okay? Instead, it has what? It has a force of friction, Fs. This force of friction prevents the car from what? From sliding and going down the curve. So what can we say now? Because the only forces on the y-axis are n and w, so we can say also the car does not move up and down. So what do we say then? We say that the normal force n is equal to the weight w. So n is equal to what? It's equal to n equals to what? N equals to mg. Perfect. This is very important to us. What can we also state? We can also state that sigma fy is equal to 0. If you don't write these, you lose marks. Pay attention. Then sigma fx is equal to what? Is equal to fs is equal to ma. Why? Because this friction, it's working, but it's preventing the car from sliding, right? But it has an acceleration, okay? So, what do we know? We know that Fs is ma. And what is the acceleration of a curve? It's v squared over r. So, ma v squared over r. We just replace the a by v squared over r. Now, what do? We start mu s equal fs over n, right? So mu s is equal to fs. What's fs? Fs, we said it's m v squared over r divided by what? Divided by n, which is what? Which is mg. So we cancel m and m. Mu s is equal to v squared over r divided by g, or times 1 over g. So mu s is v squared over r times g. So it's 20 squared over 250 times g, which if they don't give it to you, it's 9.8. So 20 squared over 250 times 9.8. So that's going to be what? That's going to be 0.16. So this is the coefficient, 0.16. Perfect. Now we move on to question number 11. A cyclist of mass 70 kg riding on a bike of mass 15 kg is accelerating at the rate of this. So let's draw the free body diagram. They said to take it as one system. So you take it as one system, both the cyclist and the bike. So in total, their mass is going to be 70 plus 15, which is 85, okay? 85 times 9.8, because if they don't give you the value of g, it's always 9.8. So it's going to be 833 Newton. This is the force down, very important. What do we also know? We also know that the normal force is acting upwards, and it's not like it's balancing out with the weight, so it's also 833 Newton. And what's left? It's the net force. Okay, so he's accelerating, by the way. Okay. And now they want to find the net force on the system. So what's remaining for us is to find on the x-axis what are the forces acting. So we have the acceleration, which is 0.80, right? And we have the total mass to be 85 kg. So by applying sigma fx equals ma, we can find that the net force of fx is the mass, which is 85, times 0.80, which is 68. So the net force acting on the system containing the cyclist is 68 newtons, and you will put it on the positive direction, okay? So the answer, my bad, over here is 68 newtons. We'll move on to question number 12. The tendency of a moving object to carry on moving is called inertia. So it's moving, continues moving in a constant speed. This is inertia. It's at rest, it continues staying at rest, it's at inertia. Now, this is all based on Newton's first law. What does Newton's first law state? It states an object at rest remains at rest, and an object in motion remains in motion at a constant speed in a straight line unless acted upon by an unbalanced force. Now, from Newton's second law, which is the force, or like the net force, is equal to mass times acceleration, we can state that the physical quantity used to describe this property is, what is it? Net force equal mass times acceleration. Net force is what? The net force, which is causing the motion, okay? But then, what do we have? We have the acceleration, but is acceleration a physical property? No, it's not a physical property. Instead, the physical property that we have in this equation is what? Is the mass. So, basically, the physical quantity used to describe this property is called mass. Now, of course, if you want to define it in another way, mass is how much inertia an object has. This is another way to define it. Like, what does this statement mean? This statement means if I have an object and I have a heavier object, is it easier? And they're both on the same surface, right? Is it easier for me to move this object, which weighs 2 kg, or this object, which weighs 20 kg? For sure, it's gonna be easier for me to move the object that's 2 kg than the 20 kg. So the more mass, the more inertia it has, meaning the greater force it needs to get out of inertia. We move on to question number 13. A person is pushing a cart with a force of 50 newtons to the left. What do they want? They want the reaction, okay? Because the person is pushing the cart. What will the cart do then? The cart will push the person, but magnitude is the same, direction is opposite, so it's 50 newtons to the right. We move on to question number 14. What does it say? It says a block of mass 5 kg is pushed along a rough horizontal surface. So this is the surface. We have a block of mass 5 kg. They told us to use G as 10, so 50 newtons, right? Is pushed along a rough horizontal surface. The block is not going up and down, right? That means the normal is counteracting the block, which is what? Which is 50 newton, okay? So what did they say now? They said the coefficient of friction between the block and the surface is 0.30, okay? They want us to find the pushing force needed to accelerate the block at 4 meters per second squared. Okay, so basically we have a pushing force in this direction and we have the friction in this direction. So they are saying that whatever we have over here is an already accelerating body. Why? Because they said they wanted to force they want the pushing force needed to accelerate the block at 4 meters per second squared. So it's accelerating. So directly, we look at where the block is moving. The block is moving left and right. That means we're dealing with the x-axis. That means sigma Fy is equal to 0 because it does not move up and down. But sigma Fx is equal to ma. What's the mass? Of the block, the mass of the block is 5 kg and the acceleration is 4 meters per second squared. And sigma Fx is equal to the pushing force F minus the friction Fs, okay? And it's equal to what? Oh no, actually this is Fk. Why? Because now the block is moving. If it's accelerating, then the Fs will change into Fk. If it's at rest or moving in a constant speed, then like the friction is gonna be Fs. But if it starts accelerating, you will change the Fs into Fk. So F minus Fk is equal to what? Is equal to 5 times 4, which is 20. Okay, this is Ma. Now, how do we find Fk? Fk is equal to mu k times n. Mu k, they gave it to us as 0.30 times the normal push n, which is 50. This will give me 15. So I will substitute Fk by 15. I will move it here. So then F is what? F is 35 newtons. We'll move on to question number 15. What does it say? They told us a body of weight 30 newtons lies on a rough horizontal table, right? So it has a weight of 30 newtons. They told us that the body is gently pulled to the side with a string at an inclined angle of 30 degrees. So this is at 30 degrees to the horizontal. The tension in the string is 18 newtons, and we need to find what? We need to find also the value of the normal push. Assume that the body moves with constant velocity. What does it mean directly? That means that sigma Fy equals 0, sigma Fx equals 0. Before we start anything, we need to resolve. We cannot keep it like this. So we need to resolve the tension. Tension will turn into tension Y and tension X. Tension Y, okay, based on triangle. Like you see, this is the triangle over here. This is what? This is tension Y, and this is tension X. So based on the triangle, tension Y is opposite to the angle, so we will use sine. Okay, so it's gonna be 18 sine 30. And then tension X is what? Tension X is gonna be the tension times cosine 30 because tension X is adjacent to the angle, okay? Now we have tension Y, tension X. Okay, my free body diagram will now look like this. This is the surface, this is the block, this is the weight, this is the normal, this is tension X, this is tension Y. What can we say now? We said that sigma Fy equals 0 and sigma Fx equal 0. They want the magnitude of the frictional force. We know that the tension is equal to the frictional force, so tension X is equal to frictional force to be more specific. So 18 cosine 30 is equal to frictional force is equal to 15.6 newtons. So for the first one, the answer is 15.6 newtons. For the second one, the magnitude of the normal force exerted by the table on the body. So what is the normal force exerted by the table on the body? We know, first of all, that it's going to be everything up equal everything down because sigma Fy is 0. So N plus the tension Y is equal to the weight W, right? So N is equal to W minus tension Y. So 30 minus 18, not cosine, my bad, sine 18 sine 30 is equal to what is equal to 21 newtons. So the answer over here is what is 21 newtons. So 21 and 15.6. I move on to question, oops, the paper fell. I move on to question number 16. A lamp hangs down by the ceiling by a chain. So what happens? The action force is the upward pull of the chain on the lamp. So what's the reaction force? The lamp will have a downward pull on the what? On the chain. So the reaction force is the downward pull by the lamp on the chain. We move on to question number 17. What does it say? Oh, 17 is a nice question. It's long, but it's nice. So first thing we do is we draw the free body diagram. Okay, I'm just gonna draw it like this. We have block, block. We don't draw this here. This is not included in the free body diagram. And then you draw what? You draw the rope to put the tension. Now two particles A and B of masses 2 kg and 3 kg respectively, okay, are connected by a light inextendable string. That means it cannot like get bigger or expand. That passes over a light smooth pulley. Okay, that means we will not consider any friction in the pulley. Particle A rests on a smooth horizontal surface and B is on an inclined smooth surface with the spring taut and the perpendicular, okay, blah, blah, blah. The system is released from rest, V initial equals 0, and accelerates. This is the acceleration. Take G to be 9.8. So directly we can put the first force, which is the weight. The weight is gonna be for particle A and particle B. Particle A, it's the mass times G. So 2 times 9.8, that's gonna be 19.6 newtons. And then for this one, the weight is down as well, like this. And how much is it? It's gonna be 3 times 9.8, which is what? Which is 29.4. Now what do we also have as well? We also have the normal push from the surface. Yeah? And then they told us it's a smooth horizontal surface, meaning we will not have any friction. So we start with the first question. What do they want from us? They want the tension in the string. You know that the tension in the string, if it's one string for both, or like everywhere it's the same string, it's gonna be what? It's the same. Or in other words, in the same string, the tension is always the same everywhere. That means if I find this tension here, I will find this tension here. So how do I find this tension? First of all, I can state that sigma Fy is equal to 0. So sigma Fya, let me be more specific. Sigma Fya equals to 0. Why? Because there's no forces with an angle, so there's no need to resolve anything. And what do I have as well? So sigma Fya equals 0 because it's not moving up, it's not moving down. Okay, what does this mean? This means the normal push of A is what? The normal push of A is equal to the weight of A, which is what? Which is M times G, which is how much? Which is 19.6 newtons, okay? Now we move on to the tension. We know that particle A rests, but particle B also rests. Now, this tension in A, there's no other force opposing it, right? So directly we can say that tension is what? Sigma Fx. It's the only force, okay? Now, this force, since no other force is acting on it, it's going to be equal to what? It's going to be equal to ma. So thus, it's going to be the value of the mass of A, which is 2, times the acceleration, which they gave it to us to be 4.5 meters per second. So the tension in the spring is 9.0 newtons. Perfect. This is to find the tension. Now the next step is to find what? Is to find the angle the inclined plane makes with the horizontal. So what we need to do over here is we need to resolve. So let's draw the x and y axis like this. I think it's preferable to draw it like this. So then we will not have to resolve the tension and the normal. The only thing we'll have to resolve is the weight. So very simply, this angle over here is theta, right? Now, the force on the x-axis and the force on the y-axis, by now, for the weight, if you're going to resolve it, you should know that it's supposed to be W sine theta on the x-axis. This is all based on triangles, so I'm not going to draw and explain the triangle. You guys figure it out by yourself. But on the x-axis, it's W sine theta, and on the y-axis, it's W cosine theta. What does this mean? First of all, we know that the object is not moving up and down. That means sigma Fy is equal to 0. That means the normal push is equal to what? It's equal to W cosine theta. On the other hand, we know from the previous one, it's the same exact thing. W of x is equal to ma. Why? Because we have a tension. And the tension versus the weight, they cannot be the same. Because if they are the same, they will cancel each other out. And if they cancel each other out, then the tension in block A is going to move block A and it's going to fall down. So this is why we say sigma of x is equal to ma. Because why does sigma of x equal ma? Because what did they tell us? They told us it was released from rest and it accelerates, right? So because it released from rest and it accelerates, that means sigma of x equal ma. There's an acceleration. So how does it accelerate? It's going to accelerate downwards because the weight is going to pull both block B and block A, okay? So due to this, we can say what? We can say that the bigger weight, W sine theta, minus the tension, okay? The bigger force minus the smaller force is equal to what? Is equal to ma, because we're dealing with the block B. So W sine theta W was how much? W is 3. The weight was 29.4. So 29.4. Let me just erase this. 29.4 sine theta minus the tension. We know that the tension, we got it from part A. It's 9.0. Is equal to the mass. Mass is 3 times the acceleration A, which we have it to be 4.5. So after solving, you will get that 3 times 4.5 is 13.5. Then move minus 9 to the other side. It becomes 13.5 plus 9, which is 22.5. So 29.4 sine theta equal 22.5. Theta equals sine inverse 22.5 over 29.4. So shift sine 22.5 over 29.4. So that will give us an answer of 49.9, which is approximately 50 degrees. So 9.0 and 49.9, which was not 30. Where am I looking? 50 degrees. Okay, now we move on to question number 18. The inertial mass of the block is 12.5. The block accelerates at 1.2 meter per second on a frictionless table when the weight of the hanging load is 15 Newton. Compare the inertial mass and the gravitational mass. All of this is a trick. What you need to know is that inertial mass is always equal to the gravitational mass if it's of the same object. So inertial mass and gravitational mass of the block are always the same. They are always equal. Question number 19. The graph below shows a variation of the force F stretching a non-linear spring with the change in its length x. So force F on the spring. They want the variation of the force by the spring. So what is this basically? It's basically the force F stretching a non-linear spring. So this is the force exerted on the spring. Now they want the force exerted by the spring. So this is what? This is action, reaction. Action and reaction must oppose first of all. So it should be opposite. And then it will be under opposite and it will be like this. So it's basically like you flip the graph because a reaction must oppose. It should be in the opposite direction. Now, last but not least, we move on to question number 20. Two blocks are connected by a string as shown below, and the upper block is pulled upward by another string. The masses of the upper and lower blocks are M1. It's in grams, so you change it to kilograms, so 0.45 kilograms and 0.15 kilograms respectively. Use G as 10. What are the tensions in the upper and lower string? Here and here. They want the tension here, tension here. So tension 1 is pulling mass 1 and mass 2. So combined, it's going to be mass 1 plus mass 2, which is 0.45 kg, 0.15 kg. In total, it's going to be 0.60 kg. So this is the mass multiplied by the G, which is 10. So it's going to be 0.6 times 10, which is 6 newtons. This is exerted by T1. And T2, the only weight acting on it is 0.15. So it's going to be 0.15 times 10, which is what? Which is 1.5 newtons. So respectively, the force of mass 1 is 6 and the force of mass 2 is 1. The force of tension 1, which is pulling mass 1 and mass 2 is 6, and the force of tension 2, which is only pulling mass 2, is 1.5. Let's submit, and hopefully we do not have any mistakes. And perfect, thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful